You know your home address by heart, but somewhere between your street and the edge of everything, that address stops making sense because your actual address doesn't end at your city or your country or even your planet. It keeps going past the sun, past the galaxy, past thousands of other galaxies stacked on top of each other. And once you write it all out, you realize something strange. You are not just living in a house. You are living inside a nested set of structures so large that the outermost one takes 500 million years to cross at the speed of light. Here's the full version. Earth, third planet from the sun. The sun, one ordinary star tucked into the Orion Arm, a minor spur of the Milky Way. The Milky Way itself, part of a cluster called the local group. The local group, one of over 100 groups inside the Virgo supercluster, and the Virgo supercluster, in turn, is just one branch of something called the Laniakea supercluster. That's your address, all of it, and you've never once needed to write it down. Start small with the galaxy you actually live in. The Milky Way is a barred spiral built from 4 major arms, like Perseus, Sagittarius, Centaurus, and Cygnus, plus a scattering of smaller ones. You don't live on any of those major arms. You live on the Orion Arm, a minor spur tucked between 2 bigger structures. That's not a coincidence. The major arms are where stars pack close together and dense star fields make life difficult, or too much radiation, too much gravitational chaos. You needed the quiet edge of the neighborhood, not the crowded center of it. So how big is that neighborhood? The Milky Way spans about 100,000 light years across, holding somewhere between 200 and 400 billion stars. Your sun sits roughly halfway between the galactic center and the edge, or about 25,000 light years from the boundary. A spacecraft leaving the solar system today would take roughly 50,000 years just to clear the outer solar system, and close to 500 million years to clear the galaxy entirely. And even with hundreds of billions of stars, most of the Milky Way is empty. Spread that many stars across 100,000 light years, and what you get is mostly nothing. A few grains of dust scattered through an enormous dark room. Now zoom out one level. The nearest large galaxy to yours is Andromeda, roughly twice the Milky Way's size, sitting 5 million light years away and closing the distance at about 120 kilometers per second. In 4 to 5 billion years, Andromeda and the Milky Way will begin to collide. Not in one clean impact, but in a long series of passes. Crash, drift apart, crash again, slowly folding into a single galaxy astronomers have already nicknamed Milkomeda. By then, nothing that exists today will be around to see it. Zoom out again. The Milky Way, Andromeda, the smaller triangulum galaxy, and a scattering of dwarf galaxies together make up what's called the local group, a structure about 10 million light years across, and again, mostly empty space. Over 100 groups like this one cluster together to form the Virgo supercluster, roughly 110 million light years wide. For decades, astronomers treated the Virgo supercluster as the largest structure worth naming. Then in 2014, astronomer R. Brent Tully and a team at the University of Hawaii mapped the motion of tens of thousands of galaxies and found something bigger hiding underneath it. They called it Laniakea, Hawaiian for immense heaven. A supercluster 520 million light years across, 5 times the size of the Virgo supercluster, made of 3 superclusters flowing together as one: Virgo, Hydra Centaurus, and Pavo Indus. Why are they flowing together? Because of something scientists still can't fully explain. At the point where these 3 superclusters converge sits a region of unusually strong gravity, nicknamed the Great Attractor. It isn't a black hole, or whatever it is, it's far too massive for that. And you can't actually see it because it sits directly behind the dense star fields of the Milky Way's own disk. Every galaxy nearby is drifting toward it anyway, pulled by a gravitational signature scientists can measure but still can't fully identify. Keep zooming out, and roughly 10 million structures the size of Laniakea make up what's called the observable universe, a sphere with a radius of about 5 billion light years. Not because light has actually traveled that far to reach you, space itself has been stretching the whole time. Light was in transit, carrying the source even farther away by the time the light arrives. And once researchers mapped this entire cosmic structure, every galaxy, every filament, every void, they noticed something unsettling. In 2020, astrophysicists Franco Vazza and Alberto Folletti compared the large-scale structure of the universe to the neural network inside a human brain, and the resemblance wasn't just poetic, it was structural. Similar branching, similar density, similar ratio of matter to empty space, which raises an uncomfortable question. Is this whole enormous dust fleck structure just wiring? And if it is, whose head is it in? Here's where it gets stranger. If the universe is 13, 8 billion years old, you should only be able to see 13, 8 billion light years in any direction. And for the most part, that holds. The farthest known galaxies sit around 13, 3 billion light years away, but you can see further than that in a way. In 1964, physicists Arno Penzias and Robert Wilson picked up a faint uniform static in a radio antenna they couldn't get rid of, no matter which direction they pointed it. That static turned out to be the afterglow of the Big Bang itself. The cosmic microwave background, the actual flash of light from the moment the universe began, now so stretched and faded, it barely qualifies as light anymore. You are, in a very real sense, looking at the birth of everything every single night, and it simply looks like static. And here's the part that should worry you a little. In 1998, astronomers Saul Perlmutter, Brian Schmidt, and Adam Rees discovered that the universe isn't just expanding. Well, it's accelerating, and it has been for billions of years. At the outer edge of the observable universe, galaxies are now receding faster than the speed of light. Not because anything is moving through space that fast, space itself is stretching, carrying galaxies along with it, which means that even a spacecraft built at the speed of light could never leave the local group. You could reach Andromeda 2 of 5 million years from now. You could not reach anything past it. The distance would grow faster than you could close it. In 2007, physicists Abraham Loeb and Lawrence Krauss ran the numbers on what this means for whoever exists far enough in the future. Eventually, every galaxy outside your own cluster will redshift out of visibility entirely. The night sky will go dark permanently and stay that way. Anyone born after that point will have no evidence the universe is expanding at all. No telescope, no equation, nothing. They'll assume the handful of stars they can see is the whole universe, because they'll have no way to know otherwise. Which means, oddly, that you're one of the lucky ones. You exist early enough to still see the afterglow, still catch the light from galaxies that are already gone from view, still trace your address all the way out to the edge of everything. You know your home address by heart, now you know the rest of it too, right? And unlike your street, this one, you will never actually get to leave.